Hello everyone, welcome to this RPG tutorial. In this we will be showing you how to create a skill tree in 2 or 3 videos. So just to show you the result of my own skill tree, you have the player here, a little slime. I will be showing you what our result will look like, or kind of similar. This is our skill room. We can move around, we can zoom out and zoom in. If we go over one of the nodes, an information panel will be shown. We can just buy the node, sell the node, and yeah, we can just keep on buying stuff, because right now there's no economy system implemented for the skills. Yeah, if you cannot sell nodes that have their children are bought or so you need to sell both of these in order to sell this one, and so on. So this is more or less what we will be doing. I believe this will take about 2 or 3 videos, so yeah, let's get started right away. We'll be initializing our project and initializing with a Git repository as well. And after that, yeah, we will start with it. So now that we have everything set up, we have initialized the project, we have started up our version control system. So now let's get onto it. In this video, what we will be doing is to just set up the camera movement, the dragging, the zooming, and that should take not that long. So let's get into it. Skill tree room. Yep. So we will be adding a node, node 2D, which will be where the actual skill tree will be stored. The nodes will be under the skill tree, and we'll be needing a camera as well, camera 2D. Yep. We need to set this as current in order for this to be the active camera when we initialize and start up everything. And under this, just for testing purposes, we will be adding a sprite, and yeah, just to see that the camera is actually moving and so on. So we'll be creating a folder here, skill tree, and we will save this scene here as skill tree room. Yeah, perfect. So now we just click here, we should get our image here, and ta-da, there it is. So dragging and clicking and zooming in and zooming out doesn't work, of course, because we need to implement this functionality by ourselves. So to do that, we need to add a script component. We need to attach a script to this camera. So we will just stop this scene here, and we'll start by creating a script. Inherits, yeah, you actually can change this later, so you don't care about this. It's going to be called skill tree camera or something. Oops, sorry. Skill tree camera. Yep, and we will be attaching the script to the camera. And this is actually a camera 2D, and we can just forget about this. So what do we want to do? We want to check the input, the user input, on maybe on every frame or only when there is input. So to do that, we will be using, we could use either the func, the process method, or we could use the input event. We'll be using this function to get all the inputs that the user is inputting via the keyboard, the mouse, or the gamepad. So we will be starting up with the zooming, because I believe that is easier. So we need to check if the event is actually a zooming event, or yeah, we could do this, or to be frank, let's go to project, start with the input mapping. We will do that first. Input map, yeah. So we'll be creating our own actions. So let's just do skill tree zoom in, add skill tree zoom out, and skill tree dot how is it, drag, maybe left click, yeah, like just left click or something. By doing this, we could just parse in the script for each and every type of input we want, like for example if we want a left click and so on, but this way you can just store in this kind of variables all the possible inputs that you can that you're going to attach to this action. So if, for example, in this case we want the mouse button, and if the mouse button for the zoom in should be the wheel up button. But if we wanted to use a gamepad, we could also use I don't know, like joy axis or a key or a joy button, whatever. Right? This is actually a pretty powerful functionality it has. So, and left click, yeah, we will just go for the mouse button, left button. Okay. So now that we have our inputs mapped, the ones we actually want, we can just go here and say if input is action, not just press, but press, because we can just move whenever we want. If we're going to zoom in, then we'll pass. And what do we want to do? Well, what we want to do here is change this property, the zoom property. We will be, this is a vector 2, yeah, and we should be changing these values. So just for the sake of checking, so that you guys can see what I am talking about, let's do a self.zoom equals vector 2 2. Okay. We click play. The thingy, the sprite looks really far away. And what if we do like 3 it's even farther. So that's the property we want to change. So we can just initialize this as 1, just leave it there, and we will need some kind of variable to set kind of the speed, because we cannot be changing this is going to be changing really fast. So if we just add 1 to the zoom level every time this function is called, it's going to be really fast. So we are going to create like a constant or something that's going to be zoom speed or something, 0.1. Okay, let's leave it at that. And yeah, so if we zoom in, the self zoom should be the self zoom plus vector 2 1 times zoom speed, right? Actually, if we're going up, zoom in should be this, and if input is action pressed, zoom out should be the other way around, right? We're adding to the zoom, and this can be checked by moving your mouse, and this kind of looks okay, but there's this thing that if you go too much, you will be in negative numbers, and that's not good. So we will be setting a minimum sum. How to do this? We'll be setting a minimum sum. I don't think max function goes with a oh no, it's only with floats. So what we can do is, because we know our sum is sum.x, because x and y are the same, we can just store this property here. And sum minus equals sum split. I think you can do this. Yeah, yep. No, actually, sum is going to be the minimum, or actually the maximum, between 1.0 and sum speed, and sum minus sum speed. This way you can make the sum be the maximum of these two values, so that when the sum goes below this value, you will always be obtaining 1. And the same on the other side, on the other direction, but mean sum, we will be creating these variables here as constants. Max sum equals 5.0. We'll be setting this here, and the same for the other one. So this plus, and this, instead of being the maximum, is the minimum, because we want this value not to be overreached, or we don't want to be over that value. Max sum, yep, and maybe we could just increase a bit the speed of the zooming. So yeah, we are there. We are already there. So we've already done the zooming. So what's left is the actual dragging. For dragging, we had this function, this action called if input dot is action press. Which one was it? Left click. Yeah. So we need to know first if we are already clicking. So we need to have a variable to store whether we are dragging or not. Initialized to false. So whenever we start clicking, that means that we start dragging. So this one becomes true. Now we can get the input. Actually, this can be obtained from the event dot position. How is it called? Because this input event, it's event. We could do if event is input event motion. Oh yeah, if we go here, we should be able to get, no, not the position. Oh, I thought we could get position. Maybe with only event mouse. Here it is, the position. And position says that it's the logo relative to the viewport. And, whoops, where are we? Relative to a corona when used with, otherwise it's 0. So yeah, we will be using the position. So we need to store the last position that was being used. So actually we can just forget about this for now. We'll just leave that there. Last clicked position or something is event.position. right? But we need to, if we want to drag, we need to create a vector out of this. So this position should be stored as a state of the camera. So let's do that. Last clicked position is a vector 2 2 0 0. And we need to initialize this with something, and this is 0. But when we start clicking, there's like the last click position could be anything. So to make the delta between the last click position and the current position of the mouse be 0, what we'll be doing is if not dragging, whoops. What we're doing is the last click position is the event.position. And then dragging is true, then we can get the delta vector 2, which is the last click position minus our current position, and then we store the value for the next frame or something. So what to do with this? Well, we need to change the self.position is equal self.position minus delta. I think it's minus because if you move from left to right when dragging, you want the camera to move to the left. So that's why there's this delta. And yeah, we also should be using const camera speed equals 0.2. I don't know. Just use this here. Yeah, as you see, I click here, I drag, and yeah, I'm clicking right now and it's actually moving. So that's some debugging we need to be doing. So first of all, this is the event position minus, right? We need, this is the last clicked position. This is the first change we need to do. Yep. Actually, the camera speed, we can forget about this because yeah, we need to move so that when we move this, it moves with us, right? And this is the actual problem right now, where when we click, whenever we click, the camera moves, and that's not what we want. So how to prevent this? What we're doing here, so let's do a little bit of debugging this. This is the dragging, just for the sake of checking and dividing everything. So we're not dragging. So because we're not dragging, we are setting our current event position. Oh yeah, we forgot about if input is action just released. Haha, we forgot about this. Then dragging is false. We forgot about this little guy here. Yeah, I was going too fast. So now whenever we release, we'll stop dragging, and then because we're not dragging, whenever we click again, we'll go through here and we will make the first delta be 0, and then everything will be from that point onward. So yeah, moving around, I release, I click again, go down, yeah, looks okay. But now I'm going to tell you another problem, because this right here looks okay. But what if I zoom? If I zoom out, I click on this little guy and I move. Hey, it's not moving at the same speed as I am. What is happening here? Well, what we're doing right now, what we're doing is moving the camera an amount of pixels every time we're moving with this delta. So actually this delta needs to be multiplied by a certain speed. I was right before in creating a kind of a speed here, but it's not the speed of the camera. The speed of the camera is always 1. What needs to be multiplied is actually the current zoom level. Because when we zoom to a level of 2, we need to be moving twice the pixels for the image to move as we want. So here what we could do is just multiply the zoom level. And now this is okay. We move out, and this is also okay. So lessons learned here. We've learned how to move around our camera. We have learned how to zoom in and zoom out. This will help us if we are going to create really big skill trees, just to show how big the skill tree is and to show the possible paths from one node to another. And yeah, this looks kind of okay. It looks good. It looks good. So in the next tutorial, I will be showing you guys how to create the actual tree structure. We'll be creating nodes here in the tree here. In the hierarchy, we'll be creating one node, and then we'll be creating all the structure, like clicking on one and enabling the other, and so on and so on. So I hope you guys learned something, and if you liked this tutorial, then just keep on watching these videos. So I'll see you later. Ciao.